Hi everyone, this is Bipin Kumar, founder of RPM Tutorial. Welcome to my channel. In my last video on calorimetry, I had talked about how the temperature change happens when heat is supplied to a substance. Okay? But that was a situation where there was no phase change involved. If it is solid, it remains solid. If it was liquid, it remains liquid, but there is no phase change involved. Today, I will talk about the phase change. We know that a substance can exist either in solid form or in liquid form or in gaseous form, depending upon the characteristic of the substance. Whenever there is a phase change involved, let's take the example of ice. Ice is a solid form, and when it melts, it comes in the water form. When it vaporizes, it comes into the gaseous form. Right? So there are phase changes involved from solid to liquid, liquid to gas. Whenever there is a phase change involved, then there won't be any temperature change. For example, if ice is melting into water, during that time there won't be any temperature change. Okay? But you have to constantly supply the heat until the entire ice melts. Because you are supplying heat, but there is no change in temperature, that's the reason it is called latent heat. You don't see the visible effect of that heat supply in the form of temperature change, because all that heat is going into the phase change from solid to liquid. Related with the latent heat, the specific latent heat term is used where it is heat supplied per unit of the mass in which the phase change is happening. So, specific latent heat is equal to the heat supplied during the phase change per unit mass. Let's try understanding the same concept of the phase change and no temperature change with this graph. If there is an ice and we want to convert that into water, we'll keep supplying heat to this combination, but there won't be any change in temperature. It will be at 0 degrees Celsius. This is a temperature time graph. So until every bit of ice is converted into water, there won't be any change in temperature. Once every piece of ice is converted into water and you are still supplying heat, then the temperature of water will start increasing. Increases up to what? Up to 100 degrees Celsius. After that, if you are supplying heat, the water will start getting converted into steam. Until every bit of water gets converted into steam, there won't be any change in the temperature. So, just on this diagram also, this phase is the phase of solid to liquid conversion, that ice is melting into water. This phase is completely water. There is no phase change involved, whereas this is water getting converted into steam. So this is a situation of phase change. Okay. Whenever there is a phase change involved, we will use this relationship. When there is no phase change involved, then we will use a specific heat capacity relationship, which is listed here. If there is no phase change involved, then we will use Q equal to mc T2 minus T1 formula. When there is a phase change involved, then we will use Q equal to mass into specific latent heat formula. Let's try understanding that with one example. The problem statement is that 5 kg of ice at minus 10 degrees Celsius is heated at constant rate until the whole of it vaporizes. How much heat is required? Let's look deeply into this problem, and then we will come to this understanding that there are 4 different stages in which ice at minus 10 degrees Celsius completely vaporizes. Let us draw a line and then try understanding the problem first, and then we will look at the solution of it. So when the ice is at minus 10 degrees Celsius, you will have to supply heat to it to bring it to 0 degrees Celsius. This is a stage where there is no phase change. Okay. After that, all the ice has come to the 0 degrees Celsius, you are still supplying heat. This is the first scenario. Then it goes into the second stage, where the ice is completely converted, not converted, rather it has reached to 0 degrees Celsius and you're still supplying heat. So ice now trying to change into water. Temperature is at 0 degrees Celsius, no temperature change involved here, and this is a case of phase change. Okay. Now every bit of ice has now been converted into water, and then the third stage comes that the temperature of water starts increasing, and it increases from 0 degrees Celsius to 100 degrees Celsius. This is a case of, again, no phase change involved. Okay. Now water reaches to 100 degrees Celsius and it is getting converted into vapor. Now here again the temperature is fixed at 0 degrees Celsius. There is no change in the temperature. This is a case of phase change. Okay. So we have a scenario where no phase change, then there is phase change from ice to water, then again no phase change, water, its temperature increased from 0 to 100 degrees Celsius, and then the phase change scenario where water is getting converted into vapor, and that time the temperature is constant at 100 degrees Celsius. Let us evaluate how much is the heat involved at each stage. First stage is the stage of no phase change. So as I told earlier, we will use the specific heat formula if there is no phase change involved. So this will be equal to M into C into T2 minus T1. Now ice is changing. There is 5 kg of ice. The specific heat capacity of ice is 2.1 multiplied by 10 to the power 3 joule per kg per Kelvin into T2 minus T1. T2 here is 0 degrees Celsius minus the initial temperature of minus 10 degrees Celsius. So this will become 10.5 into 10 to the power 3 into 10, and that becomes equal to 105 into 10 to the power 3 joule. So in the first stage, this much of heat will be required. In the second stage, when ice is getting converted into water, this is a phase change scenario. In the phase change scenario, we will use this formula because there is no temperature change. Every piece of heat which you are supplying, that is being utilized in converting ice into water. This will again go to 5. Now here we will use a specific latent heat of ice, which will be 336 into 10 to the power 3 joule per kg, and this will become equal to 5, 6, 30, 15, 18, 16, 1680 into 10 to the power 3 joule. Third stage, when water now at 0 degrees Celsius heat is being supplied and the water temperature is increasing up to 100 degrees Celsius. In this case, there is no phase change involved, water temperature is increasing, and therefore we will use this formula again. Now in this case it will be 5 into, here we will use a specific heat capacity of water because everything is converted into water. So it will be 5 into 4.2 into 10 to the power 3 joule per kg per Kelvin multiplied by, it is reaching to 100 degrees Celsius starting from 0 degrees Celsius. So this will become 5 to the 10, 21.0 into 10 to the power 3 into 100, which is 2100 into 10 to the power 3 joule. Fourth situation is that of water getting converted into vapor. And in this scenario, the heat involved is, again, because there is a phase change involved, so we will use M into L formula, and this will be equal to 5 into latent heat of steam this time we will use, and that should be equal to 2268 multiplied by 10 to the power 3, and this will become equal to 5 8 is 40, 5 6 is 30, 3 5 2 is 10, 3 13, 5 2 is 10, 11 3 40 into 10 to the power 3 joule. So total heat required to convert ice into water vapor then will be equal to capital Q, which will be sum of all these heats, and then this will be equal to 10 to the power 3 is common in all these, so it will be 105 plus 1680 plus 2100 plus 11340 into 10 to the power 3. This becomes equal to 5 15225 into 10 to the power 3 joule. This much will be the total heat required to convert 5 kg of ice at minus 10 degrees Celsius into completely a vapor state. So with this example, you might have clearly understood that when you will use this formula, which doesn't involve phase change, and when you will be using Q equal to ml, which is used when there is a phase change involved of any form, whether it is solid to liquid or from liquid to vapor. I'm sure that with this example, the concept related with the heat and the temperature change and total heat required to do any kind of phase change, all that will be very clear to you. Thank you very much.